Hello everyone, welcome back. Here we'll look through example 4. We asked to simplify this expression. Notice the symmetry. Notice how the numbers are arranged. If you have m and n, you get m and n, and then n and l, and then l and m. So we have a lot of symmetry to explore here, and this gives me hope that the solution to this problem will be very nice and neat, hopefully. So the first thing we do is to, of course, employ our indices. Notice that the first term there, here, we're going to have to worry about x to the m being multiplying m plus n. As indices, we have us all over s to the n be multiplying m plus n. Likewise, then, so over x to the n will multiply n plus l, and then l will multiply n plus l as well. So l will multiply l plus m, and then m will multiply l plus m. So what we can do is to observe that here we can simply take out we can simply apply the law of division, like a to the m over a to the n equal a to the m minus n, to see that this is equal to a to the. Now we then have a whole of m plus n to subtract m minus n, because why we have this line here, of course this is in brackets also. Why we have this line here is that it's not even a, I made a mistake. It's because of that a I wrote, so my eye just gummed it here. Now why we have this expression is because if we have x to the m and we have m plus n, if we are subtracting, sorry, not directly, if we are multiplying it by x to the m, but here is negative, you have m plus n, you find that here we have x to the m. When we're adding everything up here, m plus n can be brought out. Then we will now have sorry about that. They will now have m for this part minus n. This is what I saw when I wrote this thing down. So always useful to simplify things in your head, so that you don't waste time with too many steps. But always be sure that you are not making a mistake. So here we have verified that we are not making a mistake. So the next step is to do same thing. N plus L will come out, but then we will now have n minus L. Likewise, under x here, m plus L will come out. No, the same thing though. They will now have L minus m, L minus m. So this will be s to the m squared minus n squared. We have this because if you come over to this side here and we have m plus n, we're multiplying by m minus n. Here will be m. No, Microsoft Word whiteboard keeps changing my things. This is m squared minus mn. This is plus mn minus n squared. So these two guys cancel out and we have m squared minus n squared. That is our justification for this step here. So this is times x to the n squared minus l squared dot. So here l is the first one here, so this x to the l squared minus m squared. So then we will have to add all the powers. So this x to the m squared minus n squared plus n squared minus l squared plus l squared minus m squared. So this guy, and this guy. This is x to the 0, and then everything equals to 1. A very lovely answer. So I told you all that the answer is going to be a very nice one because of the symmetry involved. So everything here boils down to 1. Uh, very very neat. It's always nice when you have this simplification here, where and the next thing you have 1 as the answer. Students in the class will say, why 1? Why all this suffering? Why are we getting 1 mostly? But it really, it's nice when we have this expression. Thank you for watching the video, and then as usual you can check through my content and subscribe to my channel. Thank you and have a nice day.